Hello, my name is Marvin, and today I'm going to talk about naming acids. So now we need to learn how to look at the chemical formula for an acid and write a name for it. So if we're going to be talking about naming acids, let's start out by asking what an acid is. Well, there are many ways to define acid, but for what we're going to be doing here, I will say that an acid is a compound in which one or more H plus ion are bonded or connected to a negative ion. Now this isn't a perfect definition, but it's going to work really well for what we're doing here today. So now here's a list of some common acids, and we can break each one of these acids down into an H part and a negative ion part. Some of these negative ions are individual elements like F minus and F2 minus. Other ones like these negative ions are a group of elements that are together have a charge. These are polyatomic ions like this one and this one. Now just like any ionic formula, the positive charge and the negative charge has to balance out, positive and negative. That means that the charge from the H plus equal the charge from whatever the negative ion is. So in this case we have 1 H plus with a charge of 1 plus, balancing out 1 F minus which has a charge of 1 minus. They balance out together. In this case the negative ion has a 2 charge, so we have to have 2 H pluses to balance out the 2 minus charge from this. Now why am I talking so much about ions if what we're going to do is name acids? Well, it's for this really simple reason, and that is that when we're naming an acid, the name of an acid is based on the name of the negative ion that's part of that. So when I look at a formula for an acid and I want to name it, I've got to separate it just like I did here into the H plus part and the negative ion part. I've got to figure out what this negative ion is. Then I figure out the name of the negative ion is. Then based on the negative ion that I figured out, I can then know the name for the acid. So let's talk about doing with some few examples. There are really two types of acids. One that have oxygen like these, and ones that don't have oxygens like these. There are different rules for how we name them, so let's start by doing some examples with acids that don't have oxygen. So here we have HCl. And there are no oxygen here. So the first thing that I want to do is break this up into two ions that it's made out of. So it's H plus and Cl minus. So it's going to be Cl minus because the charge on the H plus must be balanced out with the minus one. So the negative ion that we're going to be working with here is Cl minus. So now the thing is, I want to know what this Cl minus is. So I'm gonna give a chart, a list of ions. These are the list of negative ions. So Cl is chloride, so we write this chloride, and we must use the rule which this. So we take a look, chloride, which ends in IDE. So we're just going to put it into hydro, between hydro and ic. So the result is hydrochloric acid. So this is HCl. Now let's do another example. HBr. Now first we're going to break this down into two ions that it's made out of. HBr. So it's going to be H plus and Br minus. So Br, it's obviously bromide. So just bromide. Then we're gonna cancel this IDE and take only the brom and put in here. So it's going to be hydrobromic acid. So it's that simple to name an acid without oxygen. An acid with oxygen, the negative ions are polyatomic ions, like these that have oxygen combined with other elements, and that group of elements together has a charge. These polyatomic ions end in ate and ite, and these endings are what we're going to be looking at when we name acids that contain these polyatomic ions. Now it's really important to be able to recognize these polyatomic ions, so you need to know what to call them when you run into them. Now here's a list of polyatomic ions, and these are only some of them. So now I'm going to give some examples. Now here's our first acid with oxygen that we're going to do, which is HNO3. HNO3. So NO3 minus is nitrate. So first we're gonna write this here, nitrate. Then we're going to be using this rule. So nitrate ends with ATE. So we're just going to take the NITR, then cross this 8. So just going to put this into ic. So it's going to be nitric acid. So take the NITR, then add IC. So it becomes nitric acid. So I'm going to give another example. So it's the acid that we're going to name is H2CO3. So we're going to break this to two parts, which is there are two hydrogens here, so 2H plus and CO3 with the charge of 2 minus, because there are two hydrogens here, so we must balance it out. So CO3 2 minus is carbonate. So we're gonna write here carbonate, and we're just going to follow this rule. So carbonate ends with an ATE. So we're just gonna add IC into here. So H2CO3 is carbonic acid. So yeah. the other type of polyatomic ions ends with a ITE. So now we're gonna do some questions that ends with ITE. Next example is HNO2. HNO2. So first break this down into two parts, which is H plus and NO2 minus. So NO2 minus is nitrite. So we're gonna write this down, nitrite. So this ends with a ITE, so we're going to use this particular rule. So just gonna move this. So we're gonna use this rule. So let's see, ITE, we take the NITR, then add OUS. So HNO2 is going to be nitrous acid. So the next example is, let me delete this. So the next acid is HCrO2. Break this down, H plus so CrO2 minus, which you can see here, is chromite. So chromite. And then we're going to take the CrOm, chrom, then add Os because it's ending with ITE. So HCrO2 is acid. So these are the rules for naming acid based on the name of the negative ions that's on the acid. So if the negative ions ends in IDE, it pairs up with hydro and IC. If the negative ions ends in ATE, it pairs up with IC. Then if it is ITE, it pairs up with Os. So now I'm going to talk about some exceptions because there are few acids that don't quite follow the rules. So there are these four acids that contain negative ions. So there are these four acids: phosphate, phosphite, sulfate, and sulfite. Okay, so if we took this acid and try to name it using the rules above, so the phosphate is going to be phosphate. So this is wrong, it's not phosphate, so actually it's gonna be phosphorus acid. So if it is phosphate, you must add a OR before the Os. So same for the phosphite. So for logically, it's going to be phosphos. So this is wrong. So it's gotta be phosphorus. Sorry. This is actually phosphoric. Phosphoric. So this is phosphoric. So this is phosphoric acid and this is phosphorus. For sulfate, you're just going to be changing it to, you're just gonna add sulfur. You're just gonna add UR and then 8, which is IC, so sulfuric acid. For sulfite, it's just the same, sulfurous acid. So this is how to name some acids that don't go by the rules. You just need to add some 2 letters. You just add 2 letters, OR and UR. For sulfur, UR, and for phosphate, OR. So now, let's say you're naming in an acid that the ions starts with a hypo or per. It's just the same, but the beginning is different. So let's say HM and O4. So break this up, H plus and M and O4. So M and O4 minus is permanganate. So this is permanganate. Just take off the ATE and follow the rules like the same as the previous one. So permanganate is going to be permanganic acid. So another one, HClO, H plus and ClO minus. So ClO minus is hypochlorite. So just cancel the ITE and then add OUS, so hypochlorous acid. So it's just the same like the previous one, but the beginning is just different. It's just a little different. So yeah, this is all from me. Thank you.